Okay, in this video we're going to take a look at how to calculate the molar mass of some different compounds, and I figured I'd start you guys off with a relatively simple compound like lead chloride. So before you begin, the first thing you're going to need is a periodic table, and you can have a calculator with you, that way you can do the math a little bit faster. So when I look at this compound, PbCl2, I notice I'm using 1 lead and I'm using 2 chlorines. So what I'm going to do is go to my periodic table and look up the atomic mass of lead off the periodic table. When you do that, you're going to see lead has an atomic mass of 207, and that chlorine has the atomic mass of 35. But instead of just writing 35, because I'm using 2 chlorines here, this chlorine has a subscript of 2, I'm going to multiply it by 2 and actually get 70 here for my molar mass of Cl2. So when I add these two numbers together, I'm simply going to add up 207 plus 70, and for my molar mass, I should get 277 grams. That is the mass of 1 mole of lead chloride. So again, I just added up 1 lead and 2 chlorine. That's why I had to multiply the molar mass of chlorine here by 2. Now I want to show you guys one that's a little bit more complicated. So this one, you'll see this compound has parentheses used with it, which can sometimes confuse students. So I want to take a look at one that gets a little bit more sticky. This is a compound of lead nitrate. So first thing, when I look at this compound, I'm going to notice that this subscript of 2 needs to be distributed to all of the elements that are inside the parentheses there. So when I add up my molar mass, I'm going to only use 1 lead, I'm going to use 2 nitrogen because this subscript of 2 gets distributed, and I'm actually going to use 6 oxygen because when I distribute this 2, I actually have to multiply it by the subscript that's already hanging off there of oxygen. So maybe I'll just leave those numbers up there for just a minute. So when I add up my molar mass, I'm going to go back to my periodic table, and I'm going to add up 1 lead, which we just looked at, which was 207. When I get to nitrogen, the molar mass off the periodic table is 14, but instead of just putting 14, I'm going to multiply it by 2. Why? Because I'm using 2 in my formula when I distribute this subscript of 2 hanging off of the end there. So instead of 14, I'm actually going to add up 28. And then for oxygen, here comes the real tricky part. The molar mass off the periodic table is 16. But instead of just putting 16, I'm going to have to actually multiply it by 6. Where am I getting the 6? It's this 3 times the 2 here. So a lot of students sometimes get confused and they want to add them, and they say there's 5. You should multiply your subscripts when you distribute. So 16 times 6, you should end up with 96 grams. Now I'm going to go ahead and add all those numbers together. Add in your calculator 207 plus 28 plus 96. Once you do that, you should get a final molar mass of 331 grams. Again, that is the molar mass. And what does that mean? That is the mass of 1 mole. So we can use this number in conversions when converting from grams to moles or moles to grams. This has been a Rodriguez original production. I hope you enjoyed. Go back and study your notes, practice more examples. Good luck.